Welcome to ATMOS 2750, day number 24. We're going to be focusing in on mercury as an air and water pollutant. So what do we know about mercury? Well, we know that mercury is liquid at room temperatures, and it's a metal. It's much more dense than water, so it will definitely sink. And it has a really low saturation vapor pressure, which means that when it's in its liquid state, it doesn't like to evaporate. So if you pour liquid mercury onto a surface and come back a month later, it'll still be there because it doesn't evaporate very readily. Mercury is very useful. It's used in lots of different products. It's used in barometers to measure pressure. We know that it's used in thermometers, liquid and glass thermometers, old style. It's used in fluorescent light bulbs, mercury vapor lamps, some batteries, some dental fillings. The metal fillings that they used to use or still do use has mercury in it. It's used in some insecticides. It's used in some cosmetics. It's used in some mirrors. And some medications have mercury in it as well. So why is mercury dangerous? Well, it's called a neurotoxin, which means that it is dangerous to your nervous system, your endocrine system, and your kidneys. Exposure over a long period of time, especially to the vapor, can lead to brain damage and ultimately death. You might have heard about Mad Hatters, and that was a profession where they used mercury to tan hides, and they did this at a high temperature, and so they ended up creating a lot of mercury vapor, and exposure over a long period of time drove the people mad because of the neurotoxic effects of mercury. The person over here on the left, I don't recommend this, is actually sitting on a vat of mercury, and since the human body is mostly water, and the mercury is 13 times more dense than water, he can actually float on top of the mercury. So mercury and its compounds are also very toxic to fetuses and infants, and women who have been exposed to mercury in pregnancy have sometimes given birth to children with serious birth defects. So what do we know about the sources of mercury? Well, we know that there are many human activities that can produce mercury to the atmosphere. The dominant one is actually coal combustion. Mercury happens to be a contaminant of the coal, and when you burn the coal, whatever the contaminants are that are non-combustible will end up going up the smokestack and out into the atmosphere unless you specifically scrub for those compounds. The most common compound in coal is actually sulfur. It can be 7 to 10% of the weight of the coal. And when you burn that at high temperature, it reacts with the oxygen to create sulfur dioxide gas. And so the coal-fired power plants in the United States and most of the ones around the world actually scrub for sulfur dioxide gas. But only in the United States do we currently scrub for mercury, and that's only been going on for the last 10 years. The process of creating cement can also generate mercury concentrations to the atmosphere. Waste incineration, there are still places where they burn waste at high temperature. And so, for example, if you break a fluorescent bulb and you throw it into the garbage and it ends up in a waste incinerator, that mercury is going to come out the smokestack. There are lots of products that we use that have mercury in them, and when they're incinerated, they all produce mercury to the atmosphere. Metal smelting, when they're trying to get the gold and the silver and the platinum and the other metals, mercury is often one of the minerals that's in there as well, and it can come out the smokestack. Gold ore can come from ore bodies that also have mercury compounds in them. The most common mercury compound is actually called cinnabar. It's very stable except at high temperatures. But some of the gold ore processing techniques, which you'll learn about next class period, can actually liberate the mercury from the ore. Other known sources of mercury include the production of steel, burning fuel oil, once again because mercury is a contaminant, and chloralkali plants, which generate lye. There are also many natural sources of mercury, the dominant one being volcanic eruptions and geothermal areas. So when you have the eruption of magma or hot springs, all of these are sources of pulling mercury from the rock and liberating it to the atmosphere. We also have some places that just happen to have high concentrations of mercury in the rocks. And one of those places in the world actually turns out to be Nevada. So Nevada has very high concentrations of mercury in the rocks, and so it can be a natural source of mercury to the atmosphere. And oceans are also a reservoir of mercury that can be a source of mercury to the atmosphere under certain conditions. As I mentioned previously, there are many consumer products that contain mercury, and these include some types of batteries, fluorescent light bulbs, thermometers, thermostats. Thermostats are used in a wide variety of things, including cars. We have our amalgam in our dental fillings. We have some thimerosal in vaccines, and there are certain automotive switches that also use mercury as well. So let's take a look at the aquatic mercury cycle. So how does mercury get into the water in the first place? Well, it's primarily through the deposition of mercury to the water surfaces or to the surrounding land and then washing into the water body. So how is mercury deposited? Well, first of all, we have to admit the mercury to the atmosphere. We have to transport it to the water body, and then we have to have it deposit. And there are two mechanisms by which you can have mercury deposition. One of those is wet, which means that it's being deposited via rain or snow. And the other is dry deposition, where the mercury molecules just happen to come in contact with the water and stick through the process of diffusion. So the most common type of mercury that will undergo dry deposition is elemental mercury, Hg0 in this case. That's your liquid metal that volatilizes into elemental mercury, Hg0, and it's not water soluble. So it will remain in the atmosphere until it impacts the ground and sticks to the ground or the water. And then we have oxidized mercury, which is in this figure Hg2. And that includes our reactive gaseous mercury and also to a lesser extent our particulate mercury. And so both the particles can be removed by wet and dry deposition, while the reactive mercury, the reactive gaseous mercury, is water soluble and can be removed from the atmosphere via wet deposition, i.e. rain and snow. So once that mercury gets into the water, then it is mixed, and once that mercury comes in contact with an anoxic layer at the bottom of the lake, there are bacterial processes that can actually methylate the mercury. In this case, we have MEHG. That's the methylation process. That happens in wetlands, but it can also happen in the anoxic layer at the bottom of lakes and streams. And once we get to methylated mercury is capable of bioaccumulating in the ecosystem. So the smallest grazers eat material that has the methyl mercury in it. It concentrates in their tissues, and then when the larger predators eat those, then they get to accumulate all of the mercury that the smaller grazers had, and then the bigger fish or the bigger predators eat the smaller fish, and the methyl mercury bioaccumulates again once away. And so you end up with the apex predators actually having the highest concentrations of methylated mercury in their tissues. And so when, as humans, being at the top of the food chain, if we then consume the animals that are the top of the food chain in these aquatic ecosystems, then we too can bioaccumulate the methyl mercury. So how do you get the mercury out of the water? Well, basically, one of the ways is you have your predators that die and they sink and they end up back in the sediment. There's also chemical reactions that can reduce the elemental mercury, the Hg0, turn it into Hg2, and Hg2 can be settled and resuspended, can basically end up in that layer at the bottom, and it can eventually be buried. And once it's buried and it's no longer in the area that's being disturbed, then it's actually removed from the ecosystem. So let's talk a little bit more about methyl mercury contamination. So there are many water bodies in the United States that are contaminated by methyl mercury. In fact, there's more than 8,700 impaired water bodies as defined by the Clean Air Act, Section 303D. There are also more than 3,000 specific fish consumption advisories, which basically tell people to limit their consumption of certain species of fish that are collected from certain waterways. This methyl mercury is particularly bad for us because it's a neurotoxin and it bioaccumulates in the food chain, and so it makes it very dangerous to eat contaminated fish and or waterfowl. So let's take a look at the fish consumption advisories and the waterfowl consumption advisories in Utah. So as you can see, there are more than 37 fish consumption advisories, and these advisories are spread out over most of the waterways of the state. So it's not like you have a whole bunch of mercury contamination in one part of the state. The mercury contamination seems to be more ubiquitous and to be a statewide phenomenon rather than a regional phenomenon. So there are many different kinds of fish in these different reservoirs and these different streams that are contaminated with methyl mercury. And in addition, the state of Utah has identified 3 species of duck which graze on the Great Salt Lake. There is a consumption advisory for the northern shoveler, the cinnamon teal, and the common golden-eye ducks. And you'll see that most of the other mercury consumption advisories are for trout. Some of those are for largemouth bass. So those are kind of the apex predators of these water bodies that are at the top of the food chain. As you move further around the state, there are some other fish that are impacted, including the black bullhead, the tiger muskie, walleye, etc. So scientists have estimated that about half of the mercury that's emitted in the United States is naturally occurring mercury, and about half is coming from human sources. And so those naturally occurring mercury emissions are coming from geothermal areas, are coming from the ocean, coming from wildfires that actually reliberate stuff that had deposited on the ground before, those sorts of things, and from naturally occurring highly enriched mercury in rocks. But from the anthropogenic, the estimates are that about 2/3 of our emissions of mercury were coming from coal combustion prior to the fact that we started scrubbing for coal combustion, scrubbing mercury out of our coal combustion about 10 years ago. And after coal combustion, the dominant source of mercury emissions is gold production and metal smelting, which together make up about 20%. And then you have a whole bunch of smaller emission sources, including the cement kilns and the waste incineration, steel production, and all the others. So where are these U.S. coal-fired power plants located? Well, primarily in the eastern part of the United States, and they're using coal primarily from the Appalachian region. In the western U.S., we do have some coal-fired power plants, and they're primarily using coal that is extracted in Wyoming and Utah. The largest coal-fired power plants in the western U.S. are actually located in the Four Corners area and up in Washington State, the Centralia Power Plant. And prior to 2012, none of these power plants were scrubbing for mercury. And now a significant fraction of them are, and the ones that aren't are the ones that are slated to be decommissioned soon, and it's just not worthwhile to spend the money to scrub the mercury out of the smokestacks. It would basically force the early retirement of these power plants. And so the government basically said, if you're phasing it out, that's fine. But if we bring on new power plants, then we're going to make sure that they have the requirement for scrubbing the mercury from that. So now that we know where the coal-fired power plants are at, where is the mining operations going on that can produce mercury? So you'll see that most of the mining operations for precious metals are actually in the western United States, and they're heavily concentrated in Nevada. So as it turns out, Nevada is a very important producer of gold for the United States. If we look at the gold production in the U.S. in 2006, a little bit old, but still accurate in terms of the amount of gold that's coming from these different locations, Nevada is producing more than 80% of the gold in the United States, with other prominent states being Alaska, Utah, and Colorado. And the gold production in Nevada is more than 7 million ounces a year, which gold prices are now closer to $2,000 an ounce, which raises that up to about $14 billion annually. So that's a big component of the Nevada economy. If we look at the gold production in the United States, you'll see that the red line is Nevada and the blue line is the total amount of gold. And prior to 1980, the gold production in the United States was fairly low, but then with the inflation that happened in terms of the economy and gold prices going up, then people started prospecting for gold and started pouring money investment into gold production. And so there was a massive increase in the gold recovery in the 1980s, and that remained largely flat for the 1990s and the 2000s. But you'll see that most of that increase of production was associated with the addition of mines in the state of Nevada. Gold prices, here you can see back in the late 1970s, early 1980s, the massive increase in the price of gold, which was associated with inflation. Then we had a massive increase in price in the run-up in the late 2000s, which was also associated with economic turmoil. And the prices remained quite high since then. And I anticipate that with the uncertainties associated with the fighting in Europe, that gold prices will remain high for the near future as well. And as long as prices are high, the gold production is going to remain high as well. And I'm not sure what to make of this, but there is a relationship between oil and gold prices. And I think that has to do with economic turmoil. So when oil prices get high, it leads in part to inflationary pressures. And when there are inflationary pressures, then people try and seek refuge in a commodity like gold, which increases the demand for that commodity, which causes the price to rise. And as it turns out, over an extended period of time, there is a fairly strong relationship between the price of gold and the price of oil. And you've seen recently that the price of oil was topping $100 a barrel. So just something else to be expected. So what are we going to do next time? So next time we're going to look at the process of recovering gold from ores and how that leads to the emission of mercury, which types of processes lead to mercury emission and which types don't. And we'll learn more about the mining practices in Nevada.